Hello everybody and welcome to Unit 9 of Regents Chemistry where we'll be talking about solutions. So we'll be looking at the different concepts and terms related to solutions, including solubility. So we'll talk about what solubility is, how is that different for ionic and molecular compounds, and then what are some of the factors that can affect the rate of solubility. So if you guys remember the concept of homogeneous mixtures, which we were talking about when we were looking at how can we classify matter into different things. So we said we can either have pure substances or mixtures, and then mixtures can be further divided into either homogeneous or heterogeneous. And homogeneous mixtures are the ones where everything appears to be one substance, which means everything is mixed together pretty well. We don't see different layers in our solution. So homogeneous mixtures are actually what we call a solution, which appears to be one substance. Yes, there can be sometimes some solid particles that we can see in there, but we don't see layers, different layers. And remember that homogeneous mixtures can be separated by distillation, which is based on the boiling point of something. So let's say you have two liquids mixed together. One of them has a lower boiling point, so it's going to boil out first, and the other one has a higher boiling point, so that's going to stay later, and that's how we can separate those two substances from the solution or mixture. So basically what happens is that we have the atoms, ions, molecules, particles of one substance that are completely dissolved or evenly distributed in the particles of the second substance. So for example, let's say you take your table salt, which is sodium chloride, and you dissolve that in water. What happens is that sodium chloride breaks down into the sodium and chloride ions, and then those two ions are just evenly distributed throughout water. They make some very weak bonds with them, but then those are the bonds that kind of like help then make that solution. So there can be different types of solutions that we can see out there. So we can have one solid that is mixed with another solid, making an alloy. So solid solutions are called alloys. So for example, here we see copper and zinc coming together to make brass. We can also have liquid solutions where we have two different liquids coming together to make a solution. For example, when we try to dissolve coffee and milk, both of those things eventually just mix together super well, giving us that one solid mixture, one homogeneous liquid mixture. And then we can also have the gaseous solutions, for example, air, which is a solution of a whole bunch of other gases. So solutions can exist in all three types of in all three states of matter. We can either have the solid solutions, liquid solutions, gas solutions, or we can also have like liquid solid or liquid gas or stuff like that. But the most common type of solutions that we see are either liquid or where we have a little bit of solid dissolved into a liquid. Those are the common types of solutions that we see every day. So let's talk about some of the vocab terms. So very first term that we need to know here is a solution. We just said it's a homogeneous mixture of two or more things. And normally what happens is that we have a solute, which is the thing that we have in a lower amount, and that is dissolved in a solvent. So these are your next two important terms to know. So let's say here we are looking at a solution of water and hot chocolate powder. Now that's our solution. In that solution, our solute will be the substance that we have in the lower amount. So for example, the hot cocoa powder. And then our solvent will be the substance that we have in a larger amount. So that in this case will be your water or milk, whatever you're using. Now, when we have a solute that can dissolve in a solvent, we say that it's soluble. If we have a solute that cannot dissolve in a solvent, then we say that it is insoluble. And in that case, most of the times it also forms a precipitate, which is like a little solid thing or solid substance that we see in our solution. For example, something that looks like in this picture. You guys also saw a precipitate when we were practicing the types of different reactions. So this is just a quick review on that. where there are a whole bunch of precipitates and then soluble and insoluble information given in table F, which we will practice moving forward in the chapter. And then solubility is basically how much of a substance, our solute, can dissolve in the solvent at a specific temperature. So solubility is temperature specific for the most part. And of course, different substances out there react differently, and you guys are given the behavior of a few substances out there and their solubility in table G. We will practice that as well as we move forward in the unit. And then last but super important term again is an aqueous solution. This should be a quick review because we have definitely talked about this word a lot. So aqueous solution is basically the solution of anything out there. We can have any solute with water. So water is our solvent in case of an aqueous solution, and then we can dissolve any solute in there. And then when we talk about the solubility of an aqueous solution, that means how much of whatever substance we are taking, how much of that solute can dissolve in a given amount of water at a specific temperature. Now let's talk about the solubility of ionic versus molecular compounds. In case of ionic compounds, a solute is evenly distributed throughout a solvent, which means we have a very uniform, homogeneous mixture where everything is just mixed really well together. And the reason for that is because when we dissolve an ionic compound in, let's say, water, those ionic compounds, because they are made up of ions, the ions can separate from each other. So we can have the positive ions and we can have the negative ions, and then they just go ahead and they're attracted to whatever their solvent is, and that kind of helps them spread out and make that uniform mixture. In case of covalent compounds, however, because they cannot break down into the individual ions, they are not made up of any ions, so they just stay the way they are. So how do they decide whether they are going to dissolve in a solvent or not? Based on their polarity. So remember the concept of polarity that we were talking about in the chemical bonding chapter. So covalent compounds are either polar or nonpolar based on the electronegativity difference in their atoms. So by like dissolves like, we just mean that if we have a polar covalent compound, it's going to dissolve in a polar solvent. For example, ammonia is a polar covalent compound. So it is going to dissolve in water. One thing that you guys always need to remember is that water is a polar compound. Okay, so remember that water can only dissolve polar solutes in it. However, if we have a nonpolar solute, then it's only going to dissolve in a nonpolar solvent. So for example, water and oil. So water is polar, however, oil is nonpolar. So both of them are absolutely not going to dissolve in each other. That's why they make those separate layers. So polar always dissolves in polar, nonpolar always dissolves in nonpolar. Now there are a couple factors that decide how fast or slow a solute is going to dissolve in a solvent. And let's look at some of those. So the first one is the surface area, which means how much area of contact do the particles have with each other. If the surface area is larger, then of course that substance is going to dissolve faster. So try this out by taking like 2 tablespoons of water and trying to dissolve 2 tablespoons of sugar in that. Because there's not a lot of surface area, not a lot of points of contact, it's going to have a really hard time dissolving. And then stirring. The more you stir something, the faster it dissolves. And then finally the temperature, which is, so remember, the higher the temperature of something, the faster that thing is going to dissolve. So you can also try this one out by taking a glass of cold water and a glass of hot water, or let's say warm water, and try to dissolve sugar, the same amount of sugar in both of them, and just see which one dissolves faster. The warm water is going to dissolve sugar faster because it has a higher temperature. Now, just one quick thing to remember about temperature and solubility. So remember that if you have a solution that has solids and liquids, then increasing the temperature is going to increase their solubility. However, if we have a mixture of gases, then if we increase the temperature, that's going to decrease their solubility. And the reason for that is because gases have the potential to evaporate. So when we increase the temperature, we are basically increasing the particle motion in the gases, and then if they are moving super fast, it's easier for them to evaporate. So think about if you have a soda can, you leave it open, what happens? The gases evaporate. So that's exactly why we need to we always refrigerate the soda if it's open, and we also want to make sure that it's airtight just so those gases don't evaporate. Now lastly, pressure technically has no effect on solubility if we have a solution that has solids and liquids. However, if we have a solution that has gases, then increasing the pressure will increase the solubility or the rate at which things dissolve. And once again, look at your soda example. I hope everyone knows that soda is carbonated water because we have carbon dioxide dissolved in water. Now, of course, water is a liquid, carbon dioxide is a gas. They cannot stay together for longer. So the high pressure that we have within the soda can is what forces carbon dioxide to remain dissolved in the water. But if you open up the can, that means you're decreasing the pressure, and then eventually what happens? The carbon dioxide is going to evaporate. That's it for now, guys. Happy learning. I'll see you in the next one.